Towards the end of a long day, thank you so much for joining us today. And yes, please grab your beer on your way over. So, the ground truth that we've all come to realize here, um, and what it means for security operations teams. Right? That's the big question here. Overwhelmingly, enterprises are adopting a multi-cloud strategy, and oftentimes it is a hybrid and multi-cloud journey that spans a period of time. It's not once and done. And so organizations are figuring out how to deal with this. Now, the second major trend is just the decentralization of how applications are built. You know, application teams get to spin up their own accounts, they get to spin up their own resources, they manage permissions, and all of that is decentralized in such a way that security teams no longer have the controls that they used to have in a data center. Credential theft, there are now just so many more credentials stored in so many fewer, in so many other places for uh, attackers to get a hold of. And this could be all the way from an intern checking in credentials in code to spear phishing in email. It's a wide gamut there. Now, with all this, the SOC is unfortunately often the last team brought to the table in a conversation about cloud adoption in general. And so the SOC team, which is used to operating in certain ways with certain tools, with a certain level of control, is now wondering, how on earth am I going to get a grasp of this whole amorphous thing called the cloud? So the big questions that come to mind: where does one begin? Is it a service? Is it an account? Is it an application stack? Where does one begin? Do I even know what the sprawl of my cloud is? The second is just SOC teams have very limited understanding of how attacks in the cloud are so fundamentally different from what they're used to in data centers, right? And then, of course, multi-cloud compounds the problem. Unlike the data center world where protocols were common regardless of which vendor you go to, now in the cloud world, everyone gets their own APIs. It just becomes a multi-dimensional problem. And then, bigger questions around cloud native application development, containerization, and then, how do all of these compare? How do I complement my CSP offered tools, right? So all of these are questions lingering in the SOC analysts and the SOC architects' minds today. And so the big question then is, with all this that's out of control and growing and changing, how can we enable the SOC to still be effective in a global multi-cloud environment? So let's start with a quick overview on how threats evolve, right? In the cloud, there are fundamentally two attack paths. There are the lift and shift organizations which have brought a bunch of VMs and similar resources from their data center into the cloud. And in this case, the cloud is treated as an extension of the corporate data center. And so there is that threat surface, and the threat vectors therein are not very different from what you would see in a data center network. The other, which is the more emergent of the two attack paths, is through the control plane. This is how does one access the cloud, whether it is user credentials or machine credentials, and then misconfiguration. I'm sure through these 2 days you'll hear at least 20 times, if not more, that misconfiguration is the single biggest cause for or origin for attacks in the cloud. So that right side is where most attacks in the cloud in the recent years have originated and succeeded. So we sort of turn our focus to how do we understand and effectively thwart those attacks. The long prevailing wisdom seems to be that of a preventive approach. So this has to do with understanding everything and knowing what's deployed at any point in time in your cloud, and then being able to understand what vulnerabilities exist in what's deployed, and finally, ensure that the configuration leaves no loopholes whatsoever. So it's a very noble goal, but in many of the organizations we've spoken to, this approach takes 2 to 3 years to get an initial handle on, and then it's an ongoing exercise to fix each of those issues identified. Mind you, the deployment may be quick, but the action on these is a long, long tail. The approach that is often brought in from the data center side is this idea of threat hunting, right? Dump all of my logs, all of the evidence that I get, dump it into a large data lake, and then try to build my own insights on top of that, right? This is very limiting in the cloud context because, one, you've got to build a lot of this on your own. Second, what you build for one cloud is not nearly as transferable to the next. And so in an organization where you have this multi-cloud approach, you're never getting ahead of it. And then each time there's a new service, you again have to start from ground up, right? So that being said, there's also the idea that the preventive is sort of, you'll never complete it, and the threat hunting approach is sort of a little too late. So then your best chance of stopping these attacks is after the attacker has come in, but before, if you detect it as they're progressing before they've reached the exit or the impact goal. So active threat detection allows the SOC to cover vast areas of the cloud very easily. It is independent of developers. The SOC gets control of their own destiny once again, because they're not dependent on who deployed what. There's no agents involved. There's none of that. And so you're able to, from a distance, deploy your tool of choice, and you're able to remediate on it in a fairly automated fashion if you get high quality signal. So with that in mind, let's think about, okay, we say active threat detection is ideal. What is the scale of the problem we're talking about? These are real numbers from one of our large customers. You're talking about 40 billion events, or basically human to machine actions that got taken during the period of even 4 to 6 weeks. It's massive. And for you to make sense out of that is a whole different thing altogether. In this whole assumption of roles and access keys somewhere in the middle, you have one unauthorized user or a malicious user. So now the question is, what is the best approach to find that needle in the haystack? Is it signatures? No. How many signatures is one going to create? Is it anomalies? In organizations which have policies that say no resource shall live longer than 2 weeks, we're going to tear down every VPC and rebuild it every 2 weeks or every month. Anomalies are the order of the day, right? So with all this in play, your only real shot is using behavioral analytics and AI to assist you with that. So let's actually look through an attack scenario, and you will see as part of this journey why, and we'll follow it up with what Vectra specifically would do for you in this case. So here you have essentially developers writing code, checking it into a code repo that then makes it through into your CI/CD pipeline, and then it's basically in your cloud. You have an unauthorized user. This unauthorized user essentially was able to get into poorly secured code repo and got credentials. Now, how is this attacker using these credentials? They're going to try to access the AWS console or through APIs, find out what they're capable of with the credentials that they have. They then essentially deploy a serverless function. They just found out that in this case, they have access to AWS Lambda and IAM. And so the attacker deployed a serverless function. What the serverless function does is each time the AWS admin creates a new user, an IAM principal, it's querying, getting credentials for that user, and shipping it out to the attacker infrastructure. So think about this. Over a period of a few days, the attacker has user credentials for a large number of different roles and then is able to impact whatever service that role has access to. So yeah, essentially, this is extreme, this level of persistence, because the Lambda does its job, disappears. It's extremely hard to find unless you actually go looking for it. Right? So now let's quickly switch over and see what the product itself would give you. Okay. There you go. No, this is still the slide.
No, this one's on. That's just the running whatever.
Mm,
No, that's not what's on.
I want, yeah, this screen. There you go. Yes. Perfect. This one is back, correct? Okay, perfect. Thank you. So what you see here is essentially what your SOC analyst will see every morning when he logs in. It's fundamentally a clean 4 quadrants with specific entities that they need to investigate at highest priority. So the top right is what we've defined as the highest criticality and the highest confidence in the attack. Um, that's something that drop everything, take a look right now. The one to the left, what we're calling high, is fundamentally things that look bad. And so you don't want to wait for it to uh, enter the top right quadrant. And then the other two are what one would consider sort of attempts or early stage attempts. Once you have cleaned out the top 2 quadrants, you can come down to that. So what is it that we are flagging? We are flagging a list of user accounts. And if that's hard to read. Yeah. It's flagging a list of user principals ordered by a combination of threat and certainty. And so what you'll notice here is on one console, you see a mix of AWS and Office 365. So this is your single pane of glass when it comes to detecting threats and investigating them across your cloud, identity, Office 365, and then soon enough your data center portfolio as well. So it's all bubbling into just one place to go look at. So let's investigate this particular example. So rather than what you're used to, which is a long chronological list of specific API calls that were flagged as potentially bad, what you have here is a specific list of what the attacker was trying to do with individual scoring for each of these behaviors. And so it's building up. You see that initially the attacker with the credentials just started discovering what's in the environment, then try to enumerate permissions from IAM to find out what do I have access to. And then you see that action on Lambda hijacking, which is where the attacker dropped in their serverless function to be triggered by any new user creation. And then Following that, you see there are two more attempts, essentially with new credentials, what the attacker is attempting to do to progress. Right? So this in one screen paints the picture of the attack for you. You are not looking at a long list of disparate, uncorrelated events. One could click down on any of these, you get some more detail, but let's click deeper to the individual screen. What you see here is a list of every single query that we found contributing towards that attack behavior. And so all of the details, including the API that was called, the response. So your SOC has no reason to have to go from one screen to then find out what's in IAM to see what the user is capable of, and then go digging in CloudTrail. Those are the sources of truth, but it's extremely time-consuming if you have to sort of manually connect all the dots in an attack. Here, it's literally one click away. So you've got all of this information. You've also got the account, the user, the principal, and what role they assumed. Here you'll see there's also the Lambda manager role that has been assumed, and the region where this attack is currently progressing. Now, as you see the attack progress, you'll see this is for the Lambda hijack. A whole different set of actions. You know exactly what sequence they were executed in. You know the details of what API was called and what the response was, and all of the details about the identity that was assumed to perform that. And finally, you'll see there's now a crossover to S3 admin role, which is basically the new credential that the attacker got after the Lambda hijack. And so now what you have here is also an attack that is spanning two different regions. So at this point, all of the top level questions and an understanding of how severe this is, how urgent this is, should have all been answered by this point. Of course, the next logical question is, okay, with these credentials and this compromised account, what else has the attacker done that has not risen to the level of a detection yet? And so there you have this idea of an instant investigation tab. And what that does is literally calls out all of the other activity, the regions, the other services that were touched by this compromised account, the roles assumed along the way, sign-ins on the console, and then just all other services that were touched. So this is a SOC analyst's one-stop shop to look for attacks, and not just within AWS, but assume a compromise began with a spear phishing attack on an admin's email, and that's how the attacker got credentials. Let's say MFA was not turned on or whatever. And then the attacker made their way in. In one place, you can essentially stitch together that breadcrumb trail, and it allows you, with the APIs that we expose on the back end, you're able to remediate it as you need to. Right? So at the highest level, this is what we do for AWS today. And just by way of, at this point, I'll switch back. Who is Vectra? So what you just saw, active threat detection and response, is who we are. It's what we do. And rather than try to be the be-all, end-all for all parts of the organization, we are focused on the SOC, security operations, as the audience. And we want to make it a cohesive journey for them across their campus. So starting from the right, essentially the data center, the identity, and SaaS, and then their public clouds. Because most of these attacks are not isolated events. They are going to travel, and you want the SOC to be able to stay with the attacker as they go to make their way through. So that's who Vectra is. We are an AWS security competency partner, and you can find us in booth 106, diagonally across the hall. Please stop by today or tomorrow, or the demo that you guys saw just now. You can take a self-driven run at it on our website. It's available. So yes, we'd love to help you out with threat detection and response in AWS. Thank you.